Hello, in this video we are continuing our discussion of section 8.6, continuing to work through example 1, and we are going to work through part D in this video. So in part D we have the function x to the fifth over 2 plus x. We need to relate it to the function 1 over 1 minus x, or really we could relate it to any of the previous functions that we've worked with in this example, since we have power series representations for them now. So let's try to relate it to the original function. So the original function doesn't have an x to the fifth in the numerator, so we could write this as x to the fifth times the function 1 over 2 plus x. But then we would need to change the 2 in the denominator and maybe a few other things, but this should look familiar to you because we've already used that function or dealt with that function in part C. So in other words, in part D, we simply have an x to the fifth times the function that we had in part C. Well, multiplying by a power of x is one of those algebraic manipulations that we can do. So what we're going to do then is simply multiply our power series representation for 1 over 2 plus x times x to the fifth. So this is going to be equal to x to the fifth times the sum that we had for 1 over 2 plus x from part C was the sum from k equals 0 to infinity of negative 1 to the k, x to the k, all over 2 to the k plus 1. That was one of the formulations. If you used one of the other formulations, that would be fine as well. And I'm going to go ahead and take this x to the fifth and bring it inside of the sum. So this means that I'm going to add 5 to my power for x. So what we have here then is the sum from k equals 0 to infinity of negative 1 to the k, x to the k plus 5, all over 2 to the k plus 1. Now, to determine if this series converges or not, remember we have two options. We can relate it to a geometric series if that's possible, or we can apply the ratio test. The ratio test is always more work, so if you can relate it to a geometric series, that would probably be the best, but it might be a bit more difficult to do that. But let's see if we can do that here. So to relate it, or to see if this is a geometric series, we have to be able to write this as the sum from k equals 0 to infinity of a r to the k. Now a and r can both depend on x. That's perfectly fine, but a cannot have any k's in it. So we have to have something involving no k's, possibly some x's though, and then something just involving x's and other constants raised to the kth power. So let's see if we can combine some things in terms of k. So what I'm going to do first with this x to the k plus 5 is write that as x to the k times x to the fifth. In the denominator, I'm going to write that as 2 to the k times 2 to the first. All of these things, including the negative 1 to the k that are raised to the kth power, I'm going to combine. So we're going to have negative x over 2 to the kth power. And these other things, x to the fifth and 2, those I'm going to write outside. So this becomes our a value, and that becomes our r value. So for the interval of convergence, then, we can say this is geometric, with a equaling x to the fifth over 2 and r equaling negative x over 2. So it converges for absolute value of negative x over 2 less than 1. And this is exactly the same result that we had for part C. So we know that this eventually ends up giving us the absolute value of x is less than 2. So in conclusion, x to the fifth over 2 plus x is equal to the sum from k equals 0 to infinity. Again, you could write any of the formulations that we have. I'm going to go ahead and write this one. So negative 1 to the k, x to the k plus 5 over 2 to the k plus 1, and this holds for the absolute value of x is less than 2. So we have our function, our power series representation, and our interval of convergence. Again, you could write any of the equivalent forms for the series, and you could write any of the equivalent forms for the interval of convergence. So you could have written absolute value of x over 2 is less than 1, or you could write -2 less than x less than 2. Okay, there are a few different options there, but you do have to have for your final answer a function equal to the power series representation with your interval of convergence.